In this section, we will be talking about symmetry. Now, you've dealt with symmetry in the real world. You know, our bodies are mostly symmetrical. We've got almost the same thing on both sides. Butterflies. I don't want to hear anybody making any fun of my drawings. Butterflies are mostly symmetric. There are lots of things that we deal with that are symmetric. In math, we're going to be looking at graphs and trying to determine if they're symmetric. So if you had a parabola, you know, it's mostly symmetric. But the thing that we're going to focus on is whether or not something is symmetric around the x-axis or the y-axis or the origin. So that's what we're going to be looking at. It will be really easy to see if you look at a graph whether or not it's symmetric about the x-axis. If it's exactly the same on both sides of the x-axis, then it's symmetric about the x. So those two lines would be symmetric about the x. And notice that if I hopped across the x-axis, my point, like let's pretend that this is the point 3, 2. If I hop across the x-axis, this is now the point 3, -2. So the only thing that's changed is the y value. The sign changed on the y value. Remember that for future reference for our test. If something is symmetric around the y-axis, so if it's exactly the same around the y-axis, then, so let's pretend this is the point 3, 2. If I hop across the y-axis, this is now the point -3, 2. So the only thing that's changed here is the sign on the x value. So if you want to test to see if something is symmetric about the x, you're going to be changing the sign of all the y's in the expression or the equation or the function. If you are testing to see if something is symmetric about the y-axis, you're going to be change the sign. You're going to change the sign of all the x's in it. Now let's look at the origin for just a minute. Now the origin is here in the middle. So let's just look at a point so you can see what happens. Let's use that same point, 3, 2. If I were to hop this point across the origin, this is now the point -3, -2. So the test to see if something is symmetric about the origin is to change the signs of both the y and the x. Now after you change those signs, what you're going to be doing is you're going to just check and see if what you get is the same as what you started out with. So let's just do a quick little example and then I'll post some more for you. So let's take a look at this one. And your directions are going to say, test for symmetry algebraically about the x-axis, the y-axis, and the origin. So what I like to do is just draw myself a little chart. And I put an x, I put a y, and I put an origin to do my algebra. And for the x, remember you change the y values. So here's my original, and I'm going to change the signs on all the y's. And then I check algebraically to see if I can clean it up at all. You know, if you square a negative, you get a positive. And notice when I do that, when I do my algebra, this is exactly the same as what I started with. So this is symmetric about the x-axis. Let's test the y now. For the y test, you change the x's. So remember that if this is an even exponent with a negative, it just becomes a positive. Evens become a positive. Odds stay negative. That's your basic math. Now notice, this is the same as what we started with. So this is a yes. So let's test both. Let's test the origin. For the origin, you change the signs of both. And we've already said that when you square a negative, it becomes a positive. When you take a negative to the fourth power, it becomes a positive. So again, this is what we started out with. So this one is symmetric to the x, the y, and the origin. Now that usually doesn't happen, especially if we're talking about functions, but this one happens not to be a function. And we could look at that to see by graphing it, but we get a yes on all of these. So that's what you're going to be doing. You're going to, for the x, you're going to change the signs of the y's. For the y, you're going to change the signs of the x's. For the origin, you're going to change both. You're doing this algebraically instead of by a graph, but you could graph these and look at them and see if they are symmetric. In fact,